Good evening, sir.
All right, good evening, everyone. Can you hear me?
Yes, sir.
Yes, we can.
Yes.
Can you hear me yet? Can you hear me? Can you hear me now?
Yes, we can.
Can anyone hear me?
Yes.
Can you hear me?
Yes.
Hello. Can I hear myself? Can you guys hear me?
Yes, sir.
Yes.
Okay, perfect. I thought I was not getting through. All right, good evening again, everyone. Good evening, Jacob. If Jacob can't hear me yet, good evening, Salvador, Clemente.
Mr. Ray.
Cannot hear me yet.
How you doing, Mr. Ray?
I'm all right. How you guys doing?
Good, good.
Good.
Good. Good morning. Sorry, good morning. Good evening, William.
Hey, Mr. Ray. Good morning.
How you doing? And good
Doing yourself?
Say it again. I'm doing well, thank you.
Hi, Mr. Ray.
Good day, Jacob. 7, 1, 2, 3, 4, 5, 6, 7. All right, perfect. I just need to get a verification of those who have taken the test, the practice test, that is.
Did you get that screenshot I sent you through
Yeah, I
Remind?
saw it. Said that you're ready.
Yeah.
I meant to write you back saying well done, but I've been swamped.
Oh, it's okay. It doesn't. What I realized, it doesn't give you an exact score of what you did, but it'll give you an estimate. So it said that I scored in within the green, so I'm most likely to pass if I were to take the actual test.
Okay, you should be able to see. You should be able to see a score if you click on the My Scores button.
Really? Okay,
Yeah,
I didn't get that far through into it then.
Oh yeah,
I
if you
just got
look back.
excited that I passed that one. I was like, wow, okay.
Yeah, I believe a good bit of you guys can pass. I already told the principal, I was like, I think I have a lot of people in my evening class that could pass it. I just got to convince you guys that you could pass it.
Right. Now,
Yeah, so,
well, I want to thank you for all your time, sir. You've done
You're
so
welcome.
much with us. You've been really good. I appreciate you.
All right, that's good to hear. I'm glad that it was an impact for you guys in your learning. And hopefully not only do you pass it, but whatever your goal is, you guys surpass even that. So
Yes.
blessings
Yeah.
to you guys all in your endeavors. I just had a few more people come in, so I'm just going to write their names down. George and Justine, welcome as well.
Mr. Ray, I'm present. I'm just coming.
Oh yeah, I just got you. Well, welcome.
Yeah. I'm just from.
So let me just show, because I had a few people who asked that earlier today. They couldn't see their scores. I haven't taken the test, but at least I can show you what you were looking for. So I'm gonna bring that up real fast. GD ready, and let me share. I'm gonna share that here. So what you do is, you log in, and what's that? Anyway, you log in. Internet's taking a little while. All right, so log in, and if you were not able to see your raw score, you just click on My Scores right here. So you click on that, and
Okay.
it's gonna bring up different things here. You just want to click on, scroll down, and you can click View All GED Ready Scores, and then it can give you even more information. Or you can go back, and if you have taken a test, you're going to see actual scores here. You have to scroll down because this is your actual GED score, and then when you scroll down, this is your practice test score.
Nice.
Excuse me.
Okay.
Scroll
Bless
down
you.
to be able to see it. Yes, bless you, whoever that was. And if you click
Thank
View
you.
All, it gives you some more information about it. But remember, the practice test is shorter. The real test is longer. It's almost 2 hours, whereas your practice test was about an hour. So you do want to make sure you have the ability to sit and focus. So, make sure that you have enough rest whenever you take the test. And you want to take it soon. I'm not sure if any of you are going to register on Monday to take the test at Fontana, but just remember, it's very possible that the seats can go by really fast because they informed all the teachers to inform all the students. So that means you could get a lot of people registering on Monday. Not to mention, when, I forget who's doing it, but when she makes it available, if you have someone in the public who is looking at that same day, they're going to be able to register as well. So just keep that in mind. If you want to take the test on Tuesday, the times, I forget the exact times, but it's like 8 o'clock, 12 o'clock, and like 2 o'clock, I believe. I think Latavia had the actual times. I don't know where I put them,
Yeah.
but that's roughly the times. So it's 3 different test times, and you can register on the Tuesday. I don't recall they never gave us a time when registration would open. And so if you really want to know, you can contact the school to see when is she opening it. I'm assuming it's going to be around 8 o'clock, but I told you guys check at midnight because I wasn't sure if it was going to be automated. If it's automated, she can do it to just do it at 12 midnight. But if it's not automated, it's just physically going in there, more than likely it'll be when she arrives at school.
So we're still considering enrolling on the 14th to be able to apply on the 15th?
For the test. The test
Yes.
is on, yeah. So that's if you
Okay.
want to take the test at Fontana. But
Gotcha.
Latavia informed us that you can take it online and that you can put the school that you're at, because, you know, Fontana wants you to take it at the school because they want the information, because they're providing the free education. So if you do take it online, if you take that option, just make sure you register Fontana to be the school to receive your scores.
Okay.
Or you can wait to January. But January, if you wait, you're going to start forgetting stuff that you learned. That's just human nature. You're going to start forgetting. If you don't use it,
Yeah.
use it.
Mr. Ray, can someone do the registration for these days other than the Monday?
Say that again?
Can I do the registration online from today up to?
No, sorry, not. That's the only day. She's only going to open it up one day, because if she opens it up any other day, all the public is going to try to get in. So
Okay.
everyone that lives around Fontana, Colton, Rialto, Ontario, Rancho, you know, they're going to be trying to register to take the test. So you got people taking SAT test, they take it at Fontana. People who are taking the GED test, they take it at Fontana. The HiSET, they're taking it at Fontana. So it can get filled up pretty quickly. Even with the COVID restrictions, they still have a decent amount of numbers, but it's just that there's so many people that can take tests. Like even for me, I have to take tests every 7 years or something like that, and I can take the test at Fontana, so I can register to take different tests there as well. So I could be sitting next to you taking a different test, if you get what I'm saying.
Okay,
Mr.
mean
Ray,
that-
I got a
that-
question.
That Monday will be.
I heard like 3 people.
Oh, sorry, go ahead.
I'm not sure who was talking first.
Oh, go ahead, George. I think you were saying something.
I believe that on Monday, okay, before 8 o'clock, most of us will be there to do the registration.
Yeah, so if I would call just to be on the safe side. If you call tomorrow, you can find out what time she's going to open up registration. That way you could be one of the first.
Mr. Ray, I have a
Yes.
question.
Sure.
Okay, remember you were saying something about only Fontana students are gonna, there's a certain day that we
Yeah,
can
that's on the
register.
14th.
That's on the 14th?
Yeah, so on the 14th, I think that's Monday, they're going to open up registration only for Fontana students. They've only told.
Okay, does that
What kind of
sound
people?
about right? I made an appointment for the 14th. Could that be the same thing?
You made an appointment as in to take
No,
the
in other
test?
words, they called me in. I called and they told me, oh yeah, we were trying to register you to take a test. Is
That's
that
for
the
your-
same test?
That's for your assessment test again.
Oh, that's
I think-
something different.
I think
Yeah.
that's your CASAS test, I believe.
Oh,
Yeah.
okay.
Yeah, I believe
Okay,
that's
so
your
I
CASAS.
still have to register then on Monday.
Yeah, if you want,
Right.
that's if you want to take the test this semester. And
Okay,
I believe this group can do pretty well. Based on what I'm seeing, most of you guys have done very well. You understand the material. You
Uh-huh.
understand enough to pass. And, you know, if you're just looking for a passing score, then jump on it.
yeah, okay. All right,
yeah.
then, Mr. Ray, thank you.
All
okay?
right? No problem.
Today I tried to sign up to take the test, to
Right.
schedule the test, and I had one opening at Fontana School on the 17th. It was in the morning, so I had to reject it because I do school with my son in the morning.
Well, if somebody's interested, the 17th, and that's going to happen. You're going to see cancellations. People are going to cancel and it's going to free up. So that was the other part of the email, that if you really want to take it, just keep on checking. A cancellation is always going to pop up. Might not be the day you want, but you will see cancellations pop up through the month. That's a given. Something pops up, the person can't make it, they cancel it, and the space pops up. So if you're trying online, you can keep checking. You might see one pop up for next week or the week after next. So thank you, Latavia, for mentioning that. That is very possible that any seat can appear between now and the end of December.
Okay.
All right, any other questions? Oh, so let me
I
Yes.
have a question to you.
Okay, go ahead.
What about if you want to do it at home? Is that possible?
For the test?
Yeah.
Well, according to Latavia, Latavia could probably answer that better than I can because I didn't know about it until Latavia told me.
Yes, you
But-
can.
Yeah, Latavia said you did it, right? You actually took a test?
Ye- For me?
Yes,
Or-
Latavia.
Oh yes, I did mine on online. I had to download a software onto my computer that they use, and then on the day of, they would ask you to take pictures of your surroundings so they can see. And once they clear that, they will log you in, and you can begin the test, and the time will count down and everything. So
All right, so you guys heard that again? Dorcas,
Yeah.
did you hear what Latavia said?
Yeah, she said I have to take picture of my surrounding, like what? My tables and all that, or what?
yeah, if you're in a room, they will ask you to take from in the front, the back, the side, on the sides. You just want to ensure that there's nothing there that you can cheat. And once they think that that's cleared, they will authorize you to start taking the test.
Now
And
is it,
the camera will be on. They'll be looking at you.
Yeah, but you can't see them, but they can see you.
Oh Lord, that's scary. Then I'm not gonna be comfortable.
Okay,
I think
let
that's
it,
how I'm gonna have to do mine because I don't have the time to do to go to the school to take it there. So
Yeah.
yeah, and it's COVID-19, a lot of changes, so that's an option. But once you're done, you can delete the software. The software is what's enabling them to use your camera. So
right.
if you're afraid of them turning it on at any time of the day after you're finished, you can delete it if you know how to do that.
Right.
Okay.
All right?
okay. I think that let's see on Monday. We'll have to meet there on Monday in the morning. Then Tuesday we go in for the exams.
Yeah, Tuesday, go for the exam. Now, I just need that information. How many of you guys actually took the exam? Dorcas, did you actually finish it? I can't remember who took it or not.
Yeah, I did. I only had like 30 minutes to do an hour questions. Some of them I guessed and some of them I knew it. And then I think the last question, it was about perimeter. I
Okay.
should have guessed on that one, but I knew it, but
Well,
by the
that's,
time I wanted to click my answer, it went off.
oh,
But it
okay.
said I was on green, that
we're
I'm
gonna-
ready to take the test.
We're going to do that for one day. I mean, one day. We're going to do that today. We're going to go over how to do the area perimeter problems and how simple it is. As long as you're good in algebra, the geometry section is a breeze. And so we're going to review that. All right, George, you took the test, the practice test, right?
Yeah, I did the practice test, but I've not seen my scores. I will check it. Maybe.
Yeah, remember, you can just click on my scores right here.
Yeah.
Click on my scores, and then once you do that, scroll down to the bottom, and you see the GED ready practice scores. William, you took yours as well, right?
Yes, sir.
Okay, and Latavia, you took the practice test, and Gennaro, you took it. Salvador, you took it as well, right?
Yes.
Sure.
Yeah, I took it.
But yours, you said your voucher did work, right? The second time you tried it?
Yeah, actually, I used the one that I purchased that day that you had us do the practice test, and then the next day, Wednesday, I did it again. So
Okay.
with the so
And
actually did it twice.
Was your score like the same, more?
I had like 3 points less on the second one.
Okay, that's fine. And remember, you can, on the test, you might get 10 points more. So
Okay.
that's good, though, that you're still in the same range.
Yes.
All right. Is Susanna on? Susanna, are you here? Okay, no, she's not. And Jacob, you took it already. And Marisol, are you on here?
Yes.
Okay, I had got your message. So Did I ever send you the voucher?
I'm not sure. I didn't check.
Okay, I don't think I did then. All right, so did you still want to try to take the practice test?
Sure.
Okay, and Justine, did you want to take the practice test?
Yeah, please.
Okay, all right, so I will send those to you at the end of class. So just, are you guys, do you have to run anywhere?
Are we gonna what?
Do you have to go anywhere? Because I was going to give you your voucher at the end of the class.
Oh, no, no.
Okay.
No, there's no rush.
All right, and did I give the voucher to everyone? Did I leave somebody out? Okay, Clemente, did I give you a voucher?
Yes, you did, Mr. Ray.
Yes, I thought so. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and 9. I just need to have record of who has used the vouchers, and then I have to return who did not. All right, so there are no other questions. We're going to go ahead and review the last unit. We didn't really get to Unit 2, but Unit 2 is pretty easy, believe it or not, and I'll see if I can even get there. I saved the last 2 units, Unit 4 and Unit 2, because they typically be done in a day. Remember, I thought we were ending next week, so I figured we would literally finish the whole book, but I mixed up the times with my social studies and science classes. So forgive me on that part, because I would have changed up how I presented the class. But we're going to go ahead and go to Unit 4, so you can get your student book out. We're going to do a quick run through of how to use the formula page and your understanding of algebra and shapes through the geometry section. All right, I'm just looking for my online book.
What page, Mr. Ray?
I don't remember the page, but it's Unit 4 in the student book we're looking at. Once I open it, I can tell you. I thought I had it open, but I obviously closed it since the last class. 4, and then
Page 94.
Yeah, Unit 4.
Yeah, page 94.
This page 94, you said?
Yes, sir.
All right. And page, yeah. All right, so that's where we're starting today. We're going to look at it. Now, we're going to use your formula page. When you're on the test, they actually have a button that you can push that brings down the formulas, and I'll show you that in a moment. But for now, what you can do, it doesn't matter what book, doesn't matter if it's a social studies book. They all have the same beginning pages. So in the beginning of the book, where the Roman numerals are, you want to turn to page 14 for Roman numerals. That's
Page 14.
XIV. XIV is 14 for Roman numerals. That's the page where you see the formula sheet, formulas. So turn to page XIV at the beginning of any book, Roman numerals 14. Now, what it looks, okay, so what it looks like on the actual test, I just have to, where is it to? Practice test, study, and preview. So if you click on this preview the test, you can do like a even shorter version of the test. It's the same questions every time, but it still gets you used to it. Sometimes it's good to do the same questions every time because in general, the questions are very similar. And they also give you the answer. So if you click answer explanation, it tells you why and whatnot. So this is, once again, if you're wondering how I got there, you click on study, and then you click on preview test. Justine and Marisol, do you guys have an account already for the MyGD?
Yes.
Okay.
Thank you. I mean, I haven't used it in a while, but yeah.
Okay, you want to make sure you could get on before the end of the night, just in case you have any troubles. I can walk you through it.
Okay.
So for the voucher part, you click this one, then you get the voucher. And that's how you take the GED ready. You need about an hour to do so. So just have an hour of free time available. All right, so preview the test is what I clicked on. This is a smaller version of the practice test. There's a lot of stuff on here. Just make sure you take time around it. Here you can learn about the computer skills you need for different question types, right? There's a lot of stuff there you can do. So we're looking at the math preview test. That's what's up here. And if you click on the formula sheet, on the real test, there's a button that you can push that brings up formula page. It looks just like the page in the book, right? Because the book and GED, they're like the same company. So it looks just like the page in the book. And that's what we're going to utilize when we find the area and all the other stuff. Also, if you don't know what the mean is, they give you a description of the mean right there, right? And we already done that before. You simply add up all the values and divide by the amount. They tell you the median, how to find the median. That's all there. This page could save your life, literally, in terms of the test. So remember, to get to it, you're looking for formula sheet. You click it, it brings up the formula page. If you forget your calculator, and let's just say no one has a calculator, they even have a calculator button that brings up the calculator that you use. And if you know how to use it, it uses the same way. You just use the mouse to actually click the stuff, but it's done the same way. All right, so this is the formula sheet, and we're going to be coming back to this because we're going to try to finish all this in one day. All right, so now we go back to triangles. No, we did not. Hold on, I need to bring up something first. I don't think we did any algebra. So actually, we're going to change that page for a quick moment. Or do we need to? Yeah, we're gonna do that. So turn to page 29 first. That's where we're gonna start. Does this look familiar? Did I do this with you guys before? I'm just gonna mute everyone.
I don't think so, sir.
Okay,
we didn't do it.
All right, so that's where we're gonna start. We're gonna start here, and so you want to turn to page 29 in the student book. Now, for some reason, they just had this little section outside of Unit 4. So that's how you build into the geometry section. So first and foremost, we need to just make sure we know what length, area, and volume is. It's basically the premise of geometry. Perimeter is basically the measurement of one-dimensional figures. It's the distance around any shape, and it's one-dimensional. So if I wanted to find, let's say your house, you wanted to put a baseboard, you know, those nice crown moldings around the edge of your room, and you needed to find out how much wood you needed for that, you would measure around the room. But it's only one measurement. It's just how long it is. And so we say that's one-dimensional. So everything that you measure here is in basic units. It's either just yards, it's meters, feet, centimeters, etc. That's it. You just say how much you need, right? It's just going around an object. It could be the outside, you know, if you're making a fence, the fence is going around the perimeter of your yard. And so that's the outside. Now, area is what we call two-dimensional, right? That's when we're looking at your computer. I look 2D right now in a sense because I'm just on the screen. So two-dimensional only has two dimensions. And so when you're dealing with rectangles, it's simply length times the width. Whereas perimeter is the length plus the width plus the other length plus the other width. But area, you may remember doing this before. Area is when you multiply what's inside. And so the length here would be 3 units. You see I put 3 boxes there. So that's a 3 there. And then my width, if you look at it, is 2 boxes on the side. And so instead of counting them, I could just say 3 times 2, which gives the same answer as saying 1, 2, 3, 4, 5, 6. So with the area of a rectangle, I can just multiply it 3 times 2. Remember, the area is what's inside of an enclosed shape. So you might find the baseboard to go around the room, but you'll find carpet to fill up the room. Or you might find tile, and so you get square feet of tile. And that's what area is, 2-dimensional. Then you have volume. Volume is 3-dimensional. So if you used to take that same room and say, you know what, I'm going to convert it into a tank that can hold water, right? That room now looks like any room in your house. It is 3-dimensional. Or any box that comes from Amazon or whatever box you may have. It's 3-dimensional. It holds space. Things can go in there. It has, you know, depth. And that's the world we live in. So if you ever go into a movie theater, when you watch the film, it's 2-dimensional, but you put on those 3D glasses, the stuff comes out right at you, 3 dimensions. And so with the 3 dimensions, you have, in terms of a rectangular object, you have length, the width, and the height. And that's what volume is. So when you're dealing with any type of box figure, you can find the perimeter going around the object. You can find the area, the space inside of the object, length times width, or you can find the volume of a 3-dimensional object. And that's length times width times height, if they're rectangular. Now remember, we have other shapes. We have triangles, we have circles, etc. And that's what we're building up to today. But we're going to be using those formulas to assist us. So let's start off with something basic here. This one says, workers at Aqua Construction Company have designed a backyard pool surrounded by a tiled area. Right, so most of you have seen a pool living in hot California. The dimensions of the pool are 5 centimeters. Remember, this is like a 3D, not a 3D, sorry, like a blueprint. So it's not the real size. But the dimensions of the pool are 5 centimeters, 2 centimeters, and 4 centimeters, right? Width, length, and depth. Each centimeter on the blueprint represents 3 feet on the actual structure. So this one asks, what is the actual volume? This means what is the real volume? Well, remember, volume is when you're dealing with something that has depth. So this pool, you can swim inside of the pool. And you could be swimming underwater saying, wee, right? That's me swimming underwater inside the pool. So we need to find the volume of the pool. And they gave us the dimensions. It was 5, 2, and something else. I can't see anymore. What was the other dimension?
4.
4. So 5 centimeters long, 2 centimeters wide, and then 4 centimeters deep. That's the scale drawing. So if you had a blueprint, use the pool guide, you're looking at your drawing, you're looking at the yard, and like, all right, I have to dig this. So they're asking what is the actual volume of the swimming pool. Now I believe this one said that each centimeter represented 3 meters. Did it say that?
Yes,
3
sir.
feet.
3
Each
feet.
centimeter represents 3 feet. So in a question like this, the first thing you want to do is convert your centimeters into real feet because they're asking for the actual volume. So in real life, instead of 5 centimeters, how many feet long would this be?
15.
15. So it's 15 feet long, right? 5 times 3. And how wide is it?
6 feet.
6 feet wide. And then how deep is it?
12.
12, right? Just timesing 3 by everything. So that means for your length, because remember the volume of a cube or cuboid is length times width times the height. And you can actually find that on your formula page. If you go over and you're like, man, I don't remember anything Mr. Ray said. Well, you look here. It's actually called a rectangular prism, just to help you out. And we'll get to that in a moment. But just to help you, is rectangular prism, and the volume is length times the width times the height. Okay, so if we come back to the diagram we have here, we have volume is equal to, come on, crazy computer. Volume is equal to, your length, which was 15, your width, which was 6, and your height was 12.
Wow.
And then you just multiply that together. You could take a calculator, or you could do it in your head if you're that savvy, or you can write it out and try it. So what would this equal?
1,080.
1,080 cubic feet. Remember, cubic feet has a 3. That 3 represents 3 dimensions. You're in the 3-dimension world, 3D world. We live in the 3D world, right? Cartoons are in the 2-dimension. So that's how you would do that one. Volume is equal to length times width times height. Now we're going to do one more problem from this section, and then we're skipping back to Unit 4. And that is going to be this section here about Figure A and Figure B. So that's page 29 in the student book. Now this is what we call composite shapes. It means, another way that it's said is compound shapes. So that means you have more than one shape that's been put together that creates a new shape. And when you do that, you're going to have to keep that in mind, that you can break apart the shape to make it easier. So this is figure A and then figure B. You could kind of think of this as a long hallway and then a room. And this is like a room in a foyer or something, right? And we want to find out, number 2, what is the area of figure A? So how would we do this? Typically, I'll wait to hear some answers, but I'm really speeding through this. What you want to do is split this up into 2 different shapes. Hopefully you can clearly see it. There's a long rectangle, which we call area 1, and then a small square. Now these little lines here, they indicate that all the sides are equal. If I was to put lines on every single shape, this is what the rectangle of figure B will look like. I'll put 1 line here, 1 line there to say that they're equal. On this line, I put 2 little lines and then 2 little lines here to say those 2 are equal. Over here, I could put 3 little lines and say that these sides are equal. Does that make sense?
Yes.
Right. So it's just to show that that side is equal to the other side. So in this one, all the sides are equal because they all have that one little stroke. And that tells you you're dealing with a square because a square is a rectangle that has equal sides. All right. So we have 2 pieces here that we can split up. So that would mean that the total area, I'll just put here area total. So the total area would be equal to the area of the first box plus the area of the second box. Does that make sense?
Yeah.
So we just find the area of the first box. And how do we do that? The area of this rectangle would be length times the width, or base times height. So that would be 30 times 250. That will give me the area of the first one. Then I need to find the area of the second. Well, I have the length, but what's my other side?
Since it's a square, you just multiply by the same number.
There you go. They're both the same size, so it's just 50 times 50, or 50 squared. And I run out of space there. And then you just multiply those 2 and add them up, and you have your area. Oh no, I messed my A up. All right, so there we go. So 30 times 250, that's going to be 7,500 in my head.
Yes.
Correct me if I'm wrong. And then 50 times 50 should be 2,500.
2,500.
Yeah. Then you just add those 2 together. The area of the first one is 7,500 meters square. This area of the second is 2,500. You add those 2 together, how much do you get?
10,000.
10,000 meters squared. Now it's important that you always have the unit there because that lets us know we're in the 2-dimensional world in terms of area, 2 dimensions. So we look down on the bottom, and which answer is that?
D.
D.
So the area of figure A is D.
D.
All right, any questions with that one?
Nope.
All right, going once, going twice, and I'm about to clear this all together. All right, so the second question, or third one rather, says what is the perimeter of figure A? Well, how do we find perimeter again?
Just add all the
30
edges.
plus 250 plus 50 square. 50 plus 50.
30.
30 plus 50 plus 250 plus 30 plus 50.
Okay, you start to see the other ones. I heard you say it.
30 plus 250 plus 30 plus
250. No, not 250 because this.
plus 200 plus 50 plus 50 plus 50.
Oh no, that's 200, right? 200 and then 50 and 50. Well done, Salvador and George. That one here is 200. Why is this one 200?
The distance has been reduced from this area here.
Right.
By 50.
Right? That part there is 50. And that part has been used up from the total. So you're not actually counting that part anymore. It's just 200 left. And so now you have all the sides, and you just add them up. So your perimeter is going to be equal to, and you can circle just so you know where you're starting. 30. Sometimes people go and count the same one again, or they leave out something. So be careful. That's one of the most common mistakes. I've even done it sometimes when I'm teaching. So 30 plus 250, make sure you don't leave anything out, plus 30, and you can do it right in your calculator if you want it, plus 200, plus the first 50, plus the second 50 plus the third 50, and then you stop right there. I just put plus 30. All right, so you add all those up, and that will be your perimeter. And let me scroll down to see what our answers will be. Any answers yet? What would be the answer if you add all those up?
770.
No, close though. Did you do it in your head?
Yeah, let me get my calculator.
Okay.
660, sir.
660, yes, it's going to be
60.
there. That's why I said close, because it's like 770, 660. All right, so 660 would be that answer there. Okay, any questions with how to do that? We're going to try number 4 and number 5, and then we're going to... Number 4 and 5 is kind of the same concept. I'm just going to skip over that. You're going to find the area of the first one, just do 50 times 15, and then the area of the second one, same thing we did, and then add them up. Does that make sense?
Nope.
Yeah.
All right, and then same thing we did for the perimeter. You want to make sure you know that this side here is 15. This side over here is 20, and then you're going to have to figure out these two sides. What do you think those two sides would be? This one's a little bit trickier, so be careful.
20 and 20.
Okay, why did you say 20 and 20?
Because it's 50 on the top, and on the bottom, instead of going 50 all the way across, you get 20 minus 10 and then another 20.
Well done. So if you see what I was saying, this one here is 10. So it has to be 20 on either side, and then that 10 in the middle doesn't have to be counted. So once you get all your sides, and I should have put those sides on the other to make it clearer. The 20 should be like here. Right, and then once you do that, you just add up 50 plus 15 plus 20 plus 20 plus 20, 10, sorry, plus 20 plus 20 plus 15. You add all those up, and you have your answer. Now, I went through that one quickly because I did want to touch on something else. Number 7. Number 7 deals with what we call volume, right? Rectangular prisms. Now, a prism, and we're going to get to that again, but a prism is basically any three-dimensional figure that when you look at the front of it, it looks like a two-dimensional figure. Now, you see these all the time. When you go to the grocery store and you pick up a cereal box, right? You just see, when you look at it straight away, it just looks like a two-dimensional figure until you turn it. You're like, hey, wait a minute, this thing's three-dimensional, right? Anything that takes that property, we call that a prism. And for instance, I have here one of my wireless speakers. If you look at my wireless speaker from the front, you're like, oh, it looks like a circle. Until I turn it, and you're like, wait a minute, that's a cylinder, right? So anything that has that property, we call that a prism. And
Mr. Resota, I don't get you. What is prism?
Everything, did you hear anything that I said just now?
Say that again, let me be clear of it. A rectangle prism has a volume.
Prism is just anything that when you look at the front of it, it looks like a two-dimensional shape. That's it.
Okay,
So
okay.
if you look at the front of a house, a traditional shaped house, right? It looks like a triangle on top of a square. But if you turn the corner, you see, wait a minute, this thing is three-dimensional. And so we have a rectangular box, a rectangular prism, and then we have a triangular prism on top. So that's a triangular prism on top of a rectangular prism. Does that make sense?
Yes.
Everybody else?
Yes.
All right, the same with the circle. Then you see a circle, and then you turn to the side, that might just be a pipe or a tunnel, you know, or a can of beans, right? A can of beans is a prism. It has a circle on the top when you look at it, and then when you turn it to the side, you're like, oh, this is three-dimensional. So anything that has that property, it is called a prism. So just keep that in mind. You can have a rectangular prism. Instead of saying a circular prism, the name for that is cylinder. Right? And cylinders can be cans, they can be pipes, tunnels, etc. All right, so For this one, it says a rectangular prism has a volume of 600 cubic feet. If the length is 20 feet and the width is 15 feet, what is the height of the prism? Remember, I already showed you guys that the volume of a prism, remember this is a prism, but when I did that little house thing there, the prism will look like that, right? The volume of a prism is the length, well that doesn't really look like the length, but it's the length times the width times the height. And so length times width times height. This is where your algebra skills come in. So the volume there is 600, right? This time they gave you the volume. So the volume is 600. They give you the length. What is the length?
20.
20.
Right? They give you the width. Is the width given in this question?
Yeah, 15.
15.
15. So you have the width. Do you have the height though? No, that's not what they're looking for. So they're asking you to find the height of the prism. So because you know you're finding the volume of a rectangular prism, and once again, if you don't remember what that formula is, you can always click the formula sheet and see that the volume of a rectangular prism, right? Rectangular prism is V equals to LHW, which is length times width times height. All right, and then so you come back to your question, you filled out the formula basically. You had volume was equal to your length, which was 20, your width, which was 15, and then you're trying to find the height. So that you already have volume, sorry. Volume is 600. So you use your algebra scales now. So how do we solve for this? Well, you're gonna have to multiply 20 times 15. That's gonna give you 300.
That's 300.
Now how do you solve for H?
You take the 300 and you put it over this.
You divide?
Divide by 300. All right, so the 600 divided by 300 is simply 2. Now, the question is, which 2? Is it A or B?
A.
B?
What do you say A?
GP is cubic.
Volume is cubic, but what are you finding?
Oh, the height. Okay, okay. Feet. It was feet.
That's feet, right? Remember, 3 dimensions. That's the first dimension. That's the second dimension. That's the third dimension. And so height by itself is just 1 dimension. So you say 2 feet. Width by itself is just 1 dimension. So you say feet. Length by itself is 1 dimension. So it's just feet. But if I was finding area is length times width, and so everything has to end with a 2 to represent 2 dimensions or 2 variables, right? Does that make sense?
Yes.
All right, so be careful.
Mr. Ray,
Yes.
Mr. Ray, please excuse me. Where do we have 300? Where did 300 comes from?
From multiplying the 20 and the 15.
Okay.
Right, we
Okay,
use the
okay.
formula, we just substitute it. If all else fails, substitute. All right, so we're gonna do one more from this page. I know I had said something else, but then I saw something, I was like, man, we gotta touch on that. All right, the last one we're doing here is number 9. It says, I actually showed this to you briefly. You may not remember, but it was at the very beginning of class when I was doing cube roots and stuff. I had shown it to you. But anyway, a cube has a volume of 27 cubic feet. Now, a cube is basically a 3-dimensional square. It means that all the sides of this 3-dimensional shape are equal. An example of that is a dice. If you ever played any game that has a die, that dice is a cube. All the sides are equal. So this cube has a volume of 27 cubic feet. What is the length of its base? Well, remember, all the sides are equal. So that means this side, which we'll say S this time, because I could say L, L, and L, or W, W, and W, or H, H, and H. But typically, when we deal with a square or a cube, we use the letter S. And actually, you will see that sometimes. I'll show it here with the square. When you look here at the area of a square, they don't show you a cube, but they show you the square. You see the square, they use S when they use the square, right? And even with the area of the square, they use S again. So whenever you see S, it's typically you're dealing with a square or a cube. And so instead of putting length and width, they just put S to represent all the sides are equal. So with this one, a cube has equal, everything's equal, right?
Yeah.
So we have equal sides on this cube. And with our side, and side, instead of saying length times width times height, what we really have is S times S times S, which is the same as S cubed. And they give us the volume, which is 27. So that means I have 27 is equal to 3 sides that are equal being multiplied by each other. S times S times S, or S cubed. So, do you remember how to solve for cubes?
Yes.
Okay, what do we do?
Length times width times height.
Okay, that's true, and that's how we get the S, S, and S. So then what would S have to be equal to? I see, Marisol, you say C as your answer. And the way that we can find it, now it's easier to find this one, and C is correct, because we can just kind of visualize. 3 times 3 times 3 is 27. But if you remember, what we do is we take the cube root, we do the opposite with the same number, and what we do to one side of the equation, we do to the other. And so in essence, we're finding the cube root of 27. And you can do that with a calculator. The cube root of 27 is 3. Now, you want to know how to do it this way, which you already know how to do. We learned this before. Because sometimes they might give you a volume that has 26.38 cubic feet. And trying to figure out what that is in your mind would be very complicated. So what you want to do is take the cube root of that number. Does that make sense?
Yes.
Right? It's the opposite. And we've been doing that with solving equations. It's the opposite operation. That's why I say, what is the opposite of squaring? The opposite of squaring is the square root. The opposite of cubing is the cube root. The opposite of multiplication is division. The opposite of addition is subtraction. And that's how we solve. We do the opposites. And with geometry, you're going to be doing a lot of that. All right. So now we can go back to page 94. Now remember, as long as you know what the shape is, you can just look at the formula, and then everything else is your algebra skills. And hopefully your algebra skills are still good. All right, so a triangle, everyone knows what a triangle is, right?
Yeah.
But when you see this shape, but they don't tell you what it is, you know that you're looking at which formula on the formula page? The one that says what?
Half base times height.
There you go. So when you're finding the area of a triangle, half base times height. Right there on the triangle, which means all you need to do is identify what the base is and what the height is. And if they give you the area, you're obviously going to be finding one of the others. All right, so we're going to do that here. Also, you see here they talk about something called a quadrilateral. A quadrilateral is just a four-sided figure. And the reason why, because not only do you have rectangles and squares, but you also have what we call parallelograms, which can be slanted. And then you can have parallelograms that have equal sides, and we call those rhombuses. So when something is like slanted like that. And then you also have diamonds, right? Like a baseball diamond. That's a 4 diamond, but a diamond has 4 sides as well.
On which page that you are operating? Which page is that?
Page 94.
Okay.
All right, so anything that has 4 sides is called a quadrilateral. So what we want to do now is look at how to find that. We saw that the area of a triangle is half base times height, and that's because every triangle, no matter what the shape of the triangle, is always half of a rectangle. So basically, you're taking the formula of a rectangle, and then you're halving it, right? No matter what type of triangle, because every rectangle can be halved by drawing a triangle. So even this right here, this shape is half of the rectangle. And the other 2 sides that have been made, they are equal to the other side. So the part that's in blue, if you add these 2 triangles together, they add up to the red side. Pretty remarkable, happens every single time. And that's the beauty of mathematics. But a triangle is always half of a rectangle. And therefore, it is always half base times height. And this can be proven in many different ways. The ancients already knew it. The Egyptians knew it. A lot of people knew it. Babylonians, the Chinese, ancient cultures, and Aztecs, Incans, Mayans, they all knew about this formula. So anyway, half base times height. We're going to skip this one because we already done that, and we're skipping that one too. All right, number 4 and number 5. How do we find the area of the triangle? Once again, if you forgot the formula, you're on the test. Like, man, I forgot it. You go back to the formula sheet, right? You click on formula sheet. Up pops the formula. You're looking for the area of a triangle. All right, area is here. Triangle is here. Okay, that's my formula. Does that make sense?
Yeah.
Right? That's how you want to tackle anything that you may have not gotten to. Formulas are on there to save your life. All right, so how would we find this one? What formula are we using again for number 4?
A equal to half.
Times 24 times 13.
That is D.
Close. So let's break it up first. We're looking for the area, so we know we're going to have A. And then we have half of the base. What is the base of the triangle?
24.
24. Now be careful. This is where most people mess up, and they have the answer down there more than likely. I'm pretty sure they do. Let me see if they do. Yep, they have the answer there if you mess up. What is the height of the triangle?
13.
No.
5.
5 is the height of the triangle, right? Think of your life. If you were walking up a 13-inch ramp, when you get to the top, you don't say that you're 13 inches high. You say that you are 5 inches high, right? The ramp just got you up to the height. So the height of that triangle is 5. If you use 13, the answer is there if you use 13. That's a very common mistake. But the answer, the height there is 5. So you multiply that out. You can do it in your head or use a calculator. Half times 24.
16.
60.
12 times 5 is 60. Now remember, the answer is going to be inches squared.
Wow, Mr. Ray, I made a mistake. I was thinking of 13.
Yes, if you use 13, it'll give you this answer, 156.
Yeah, it'll give you D.
Yeah, and they normally have it there. Whatever is the common mistake, they will have the answer there for the common mistake. So you have to be careful. And that's why some people, like, they're alarmed. They're like, man, I thought I did well. It's because if you make the mistake, they have the answer there if you make that mistake. And that's how they're able to see who really knows it. All right, number 5. What is the perimeter? Don't think too hard. How do you find the perimeter of any shape again?
We multiply at all the sides.
All the sides.
All the sides. So just get everything up right there. Right?
And that's it.
50.
That's it. Just add up the sides. 13 plus 13 plus 24. What does that equal?
50.
50, right? And notice there's no numbers there because perimeter is 1 dimension. So you just say inches. Whereas area, which is 2 dimensions, you put the squares there.
In cubic, 3.
Does that make sense?
Yeah.
All right, perfect. Okay, moving on. Sometimes they, actually no, there's another shape here, I think. Parallelogram. So some people are like, parallel what? Well, that's called a parallelogram. It means that you have a parallelogram. If you know gram is kind of like a shape or figure. So a parallel figure, that's what it's basically saying. And they just put that O there. But parallelogram, how you say that. It's basically similar to a rectangle. Think of it as somebody built a poor building that starts to slide. And the foundation just slid over, right? So notice though, what is the height? Is this the height of the parallelogram?
No.
No, the height is here, right? Remember, height is always straight. Height is not diagonal. So that's our height. And the question says, what is the perimeter of the parallelogram? We're going to need the height for number 7. So let's just do the perimeter real fast. What would be the perimeter of this shape?
61 meters.
Say that again.
61 meters.
Okay, well done. 18 plus 18 is 36. 12.5 plus 12.5 is 25, and 25 plus 36 is 61. And that would be correct. That's your answer for the perimeter. Perimeter questions, you should get all perimeter questions right, hopefully from this point on. area of the parallelogram. Does anyone know what the area of the parallelogram is? The formula.
18. Width times height.
Yeah, it's base times height or width times height. And if you weren't sure, once again, you can go to the formula page and you can look for area, because that's what we're doing. We're dealing with the area of a parallelogram, which is base times height, which is no different than length times width. You can even say base times width, or you can say width times height, whatever you want to say. It's basically just multiply the dimensions, right? The horizontal and the vertical. All right, so base times height. So you look for the base of that parallelogram. What is the base?
18.
18, and what is the height?
The base is 15.
We don't know the height, but
We don't know the height, right? So, and that's actually what we're looking for. They're actually to find the height. So that means we need to know the area. Did they give us the area of the parallelogram already?
no.
50, yeah.
Yeah, 450
450.
square.
So we have 450 is equal to 18h, and how do we solve for h?
Divide both sides by 450.
No, divide both sides by
Divide.
by
18.
18. Remember, you're going to get the h by itself. So we want h by itself. We divide by 18, so the h will be by itself. It cancels on the right side. Well, what you do to one side of the equation, you do to the other.
Okay.
So now you just
25.
find out what 450 divided by 18 will be.
25.
25.
25 is correct. So 25 meters is the height of that parallelogram. Pretty straightforward, right? Hopefully this is looking really straightforward for you.
It is.
Right? And so that's how you tackle geometry. It's just basically you got to identify the shape. Sometimes they ask different things, like this one where they give you the area and ask you for the other dimension. All right, we're going to skip by
Mr. Ray should be. Just go behind. Let me ask something. Mr. Ray?
Yes, go ahead.
Yeah. Well, what is the base of that parallelogram? I don't know the base because I'm seeing
The base
the
is
base.
18.
Where do we have 15? Because I know of the height of 18 meters and 12.5 on the side.
This is not the height. This is not the height of the parallelogram.
Yeah, this is the height. Where is the base? That's my problem.
No. Okay, the 18 is the base. This is the base right here.
Okay.
18 is the base, and this h is the height.
Okay, then.
When you measure the height of something, let's say this was a letter, right? Let's say this was a letter on top of a house, right? You don't say that the letter is the height of the house. You measure the height of the house by measuring the vertical distance from the top to the bottom. And that's what this is. When you look here at this dashed line, the dashed line is representing the height between the top and the bottom.
Okay, this is the height. Then the base should be half of this because the base should be 9.
No.
Okay.
Are you trying to find this right here?
Yeah, because I was thinking of the base could be half of. Okay.
No. Okay, just follow the formula. Whenever you see a parallelogram, it's base times height. The base, just like the base of your fan or the base of your light post or the base of a flag, is whatever's on the bottom.
Okay. Yeah, thank you.
That's the base. Okay. And then the height is always going to go up from the base. So it'll be it's always a straight line.
What I made that mistake was because I was just thinking of the triangle, which is half of the base. So I was thinking that this could be half also.
Oh, okay. So I guess this threw you off right here.
Yeah.
So the reason why, and this is for anyone else, the reason why this is a dashed line is just trying to show you that the height of a parallelogram is from the two parallel sides that are where your base is. But you do not measure from the slant.
So hard to concentrate.
Very careful. The slant is what you measure.
No!
Someone's mic there. All right, so anyway, any other questions there? Because that's going to come up again, and hopefully
So for number 6, the answer was B.
Yeah.
It was B, yeah, 61.
Okay.
Right, adding up all the sides. 18 over here, 12.5 over here.
Okay. Just making sure that's what I did.
Okay, no problem. Right, remember parallelograms can be tricky. This is not necessarily a triangle. It's literally like this is not there. This is literally what they have. It was literally like this, but what they're trying to help you with is that in order to find the height, you actually have to measure down from that line to the other line. Now, in the next section, there's a way to find it if it's not given to you. And that's a Pythagorean theorem, but we're not going to have time for that today. But I'm just going to mute everyone real fast. I keep thinking someone's talking. All right, so this would be good if you can get this under your belt. And we've done it already. The distance formula that we did in graphing comes from this. This is literally the distance formula. But Pythagorean theorem, it's named after Pythagoras, but it existed before he was even born, as a lot of civilizations had it, and he borrowed it from someone, and then it's named after him. But Pythagorean theorem is just a way to find the missing sides of a right triangle. It's not that hard to learn. Try to read over it on your own before you take the test. You'll be surprised how easy it is. But I really want to make sure we understand the concept of algebra. And so with that, we go to what we call polygons in lesson 3 on page 98. And if we have time, I'll go back to it. But page 98 is what we're on now. And we're with polygons. Now, polygons just means many sides, right? Poly means many. And that part gon is part for sides. So a polygon is just any type of shape that has 3 or more sides. You can't make any shape with 2 sides. It's impossible. You need that third line to enclose the shape. So assuming you get any enclosed figure, no matter what that figure looks like, that's called a polygon, right? Now you have irregular polygons, which looks irregular. And then you have regular polygons, which actually look nice and symmetric, right? And then you can have crazy, all sorts of types. You can have 3 sides, 4, 5, 6, 7, 8, 9, 10, 58 sides, right? But the common ones that we know of are triangles, which are 3-sided figures, squares and rectangles, which are 4-sided figures. And then you go on to pentagons. Anyone heard of the Pentagon in Washington, D.C.? Pentagon has 5 sides, and it looks like, that's not a good drawing that I did, but anyway, it looks like that, right? It can look like that. That actually looks a bit crazy. Hold on. Pentagon will look more like this. I'm having a hard time drawing it. There we go. So that's a pentagon. The Pentagon in Washington, D.C. is named that because it's shaped like a pentagon. And then you have a hexagon that has 6 sides. You might have heard of that. Sometimes you hear it in witchcraft and stuff like that. They use a hex. If you ever heard that before, that's because witches use the 6-pointed star, which is a hexagon. And then you have an octagon. Most of us know about octagons because when you get to a stop sign, that's exactly what you see. A stop sign is an octagon that has 8 sides. And they are all, most times, regular polygons. Regular polygons just means that they have congruent sides. That word congruent is just a geometric name to mean equal. So if I have 2 computers that are exactly the same, I can say that they're congruent. And that just means that they are equal, right? It's just when you say congruent, people know you're talking about geometry, versus when you say equals, people think algebra and arithmetic, right? So congruent just means equal shapes. Okay, then you have incongruent, as I said, just means the opposite of congruent, which means not equal. And these are with irregular polygons, polygons that look crazy. Like if my eye was up here and my other eye was here, you say he looks irregular, right? Or if you're not feeling well, you might say you have irregularity, right? So what we're going to do now is just kind of review that. Here you see a regular polygon. It looks really nice and symmetric. And then you see an irregular polygon. The 2 sides here are different and the bottom. This one here, the irregular polygon, looks more like the front of a house. But if you were asked to find the perimeter, just like any other shape that we've done so far, you just add them up. And sometimes it helps you just make a marker where you're starting. 8 plus 8 plus 8 plus 8 plus 8. But because you're dealing with a regular polygon, which has equal sides, instead of adding 8 5 times, you could just say 5 times 8, which is a shortcut. That's exactly what we do with a square. With this irregular polygon, because the sides are different, I need to add them up individually. So 8 plus 7 plus 12 plus 7 plus 8, as you see here. All right, so perimeter, as I said before, is typically the easiest thing to find. And remember, if you have a compound shape, you just split up the shape. Let's just try to see if you get it. This is a regular hexagon. So a regular hexagon has a side length of 5 inches. What is the perimeter of the hexagon? Remember, regular means that all the sides are equal. How many sides does a hexagon have?
6.
Right, a hexagon has 6 sides. And how much is each side? And
5 times 6, 30.
okay, so 5 times 6, which is 30 inches. All right? Or you could have said 5 plus 5 plus 5 plus 5 plus 5, and that takes too long. So 5 times 6 gives you the 30. And done. Right? That's how you find the regular polygon. Here we have an irregular polygon, and they're actually find the perimeter, and you just add them up. 8 plus 9 plus 12 plus 9 plus 7. And how much would that be? 9 plus 9 is 18, is 26, and then, man, my brain's tired already, 33, 45. So that one would be 45 feet just by adding them up. All right, that's what we call polygons. So you see here, this one here, a regular pentagon. Notice they don't tell you how many sides. You have to know that a pentagon has 5 sides. Here, they don't tell you how many sides it has. It only says an octagon. And so you need to know that an octagon has how many sides?
6.
No, 8 sides. Remember, octagon is the stop sign. When you get to that stop sign, that's an octagon, that this red stop sign with the white writing says. That's an octagon, 8 sides. So you make sure you want to know that, because although you may know how to do the multiplication or the addition, you have to know how many sides each thing states. So a pentagon has 5 sides. Hexagon has 6 sides. An octagon has 8. And they left out one, 7 sides we call a heptagon. I doubt they're going to go higher than 8, but the other ones are called a nonagon for 9 sides and a decagon for 10 sides. I forget what 11 is, but 12 is dodecagon. All right, so that's just to show you that perimeter, just you add them up. Now, they don't have a question on the student book for trapezoids, but I do want to go over this one here. We're going to do what is the perimeter of this trapezoid? Did I hear an answer? Okay, thought I had an answer there. Okay, so the perimeter
46.
of this, how much?
46.
46. So I have 46 inches by adding up all the sides, and so C would be the answer. Now, like I said, they don't have the area question on here. The sad thing is, it's probably in the workbook, so you definitely want to try the workbook questions. My computer's about to die. All right, where was I? So we're going to find the area now of a trapezoid. Like I said, it's not written here. So we're going to find the area of a trapezoid. So the first thing you want to do is find out what is the formula for a trapezoid. Can anyone look on the formula sheet and tell me what is the formula for the area of a trapezoid?
Area equals
Half base of base 1 plus base 2.
There we go. That's the area of a trapezoid, right? You go to the area section, you find trapezoid, excuse me, and then you find the formula. Right, once you know what the formula is, Everything else is just being able to identify it. And this is where you want to pay close attention.
Of height.
Just like the parallelogram, you have to be careful with identifying the sides of a trapezoid. It's pretty similar. You don't want to use the slant. It's very tempting to use the slant in a trapezoid, but that's not what you use. What you use is the bases. Now the formula is half times base 1 plus base 2 times the height. I wrote it a little bit differently, but still the same. All right, so first thing you want to do, if you're finding the area, and let me scribble out these answers. We're doing the area for this one, is to first know what B1 and B2 stands for. Does anyone have any idea what B1 stands for?
No.
It means base 1
base 2.
and base 2. Now the question is, what are our bases? The bases are the parallel lines. Parallel means they never touch. So these, how my hands are situated, that's parallel.
So
My hands are this way, that's parallel. My hands are diagonal, parallel. It means they can never touch. You see, if this line was extended and this line was extended, that's not parallel. They would eventually touch. So what are the parallel lines? I heard somebody about to say it.
5 and 3.5.
5 and 3.5. That's my base 1 and my base 2. If I was to turn this thing on its side, it would make more sense as to why this is the base 1 and base 2. If you saw it like this, you can see that if this was standing upright, 5 would be the base 1 and 3.5 would be base 2. Does that make sense?
Yes.
Right, so they're always parallel. You have to remember that. You put an asterisk next to that. Most people who make a mistake with trapezoids make a mistake right there in identifying the base 1 and the base 2. All right, so now that we've identified the bases, we need to figure out which one represents the height. Now there are 2 left, so which one do you think represents the height?
18.
18. Be careful of that 19.5. Remember, the height will always connect 2 parallel lines, right? The height of something, when you find your height, you find your height to a parallel, right? That's why you parallel your head to the wall. The parallel line, the other parallel line is the floor. And so your height is the distance between the floor and the parallel line that you put above your head. It's the same thing here. The height is always connecting the parallel lines. Does that make sense?
Yes.
So the height is 18 or 19. I was thinking it should be 19, 19.5.
Did you hear what I just said about the distance between the parallel lines?
Yeah.
So which one connects the parallel lines in a height type format, in a straight line form? 18. Right, so when you measure yourself, right, this is the floor, and this is the wall that you stand against, and then somebody takes a ruler and they put it above your head and they measure the parallel lines in between, and that's how you find your height. The height is always connecting via a straight line, the 2 parallel. That make sense?
Okay, yeah, thank you.
It's the same thing with the parallelogram, right? When we measure, we do not measure diagonally. We always measure in a straight, vertical or horizontal manner. All right, so with that said, our height again is which one?
18.
18. Once you're able to identify the parts of the trapezoid, the rest is algebra. So you say trapezoid, I find my base 1, I find my base 2. They're always parallel to each other, and the height connects the parallel lines in a vertical or horizontal way. Never the diagonal line. The diagonal line, sometimes we nickname it a slant height, and we do that with cones, but we never call it a height. So we now have all of what we need. So we have area is equal to a half times base 1. What's my base 1?
5.
5. What's my base 2?
3.5.
3.5. And what's my height?
18.
18.
Okay, and now everything is algebra. We follow the order of operations. So we start with our parentheses first. 5 plus 3.5 is 8.5. And then we can put that straight in the calculator or work it out ourselves. Multiplication is associative. So I could say a half times a 9 first. or I mean 18, or I can say half times 8.5, but you just multiply that all together. Remember, you can use your fraction bar in the calculator, the n over d button, to write the 1/2. So that's 1 over 2. So that's 1 over 2 times 8.5 times 18. And what would that give us?
This is 76.5.
26.5.
76.5. Now remember, this is none of these ones, so don't get confused. So that's 75.5. And what unit would I write? Inches. And what else would I need?
2.
2, right? Inches squared. So a power of 2. All right, and that's how you would do a trapezoid. Any questions about the trapezoid?
So my question is, because with trapezoid, I was thinking where you said the base 1, base 2, I was thinking those were the length. So base 1, base 2 are the length or what? The side? I don't know.
They're parallel. So remember, parallel means they never touch. Like your walls of your house, if they were to touch, your house is falling in. Right? Your walls will never touch, right? On the opposite side. So the bases are considered anything that does not touch, cannot touch if you were to extend it. So if I was to extend this line here, like just to act like it kept on going, notice this will eventually touch with the bottom line. So that means these lines are not parallel to each other. So that means I'm looking for the lines that are parallel, which are these two. All right, does that make sense?
Yeah.
Okay.
Yeah.
We're gonna try a little experiment real fast. Do you guys see my internet browser?
Yes.
No. I was looking for something that had a lot of trapezoids on it. Let me type in a worksheet. What? That's why you gotta use Google. I can't get to Google. Let's get to Google. All right, so all we want to do here is just identify what are the bases. That's all we're going to do. What? Let's see if I can open this another way then. This one. Do I click on it? I don't want that. Anyway, we're just going to zoom in there. All right, so which one is the base? What are the bases on the first one? Number 1, what are the bases for this trapezoid?
9.
9 and
9
and
7.
7. That's base 1, base 2. It doesn't have to be in any order. You could have said base 1 was 7. But do you see it? They're parallel to each other. How about number 2? What are your bases?
12 and 8.
8 and 12.
And 12, right? They are parallel to each other. How about number 3? What are the bases?
6 and 5.
5 and 6.
5 and 6.
Number 4.
9 and 7.
9 and 7.
Back to number 1. What is the height? I know it's easier to see because it's 5, right? 5.
5.
Oh, sorry.
4.
4. How about number 4? What's the height?
6.
6.
Right? It's always connecting the parallel bases. The bases are parallel to each other, and the height is what connects it. And if you look at a trapezoid carefully, you see that a lot of buildings and a lot of other objects are shaped similar to trapezoids. A lot of rooftops look like trapezoids and whatnot. All right, so that's the basic picture. How about number 5? What is the base 1 and base 2?
14 and 6.
14 and 6. You guys see that parallel? How about number 6? What are the bases?
6 and 11.
6 and 11, because the lines on the top parallel. If you're to extend them, they will never touch. Because they'll never touch, they are the bases. That's how we determine it, even if it's turned upside down, right side up, because these lines never touch, right? If I was to extend them, they will never touch. Those are the bases. Whereas here, if I extended this line and this line, oh no, they're crossing, so they're not parallel. And hopefully that makes sense. All right, so back to the other thingy. And I see something in the chat. Oh, let's see. Do you guys see my paper now?
Yes.
Okay, perfect. So we're basically done with that. That's all you need to know about polygons, because they're just going to have to either find the perimeter of the polygon or the area of a trapezoid. Remember again, find the area of a trapezoid, if you forget the formula, is right there. And what does the base 1 and base 2 represent? The parallel lines. And what does H represent? The distance between them. All right, so we're done with that. Any other questions before I move on? All right, circles. Everyone knows what a circle is, right?
Yes, sir.
Yeah.
Okay, good. Now, math-wise, what a circle is simply the set of points that are a fixed distance from a central point. What that means is, if I was to have a stake in the middle of a ground, you could draw any circle using this method. And I tied a rope from that stake, and I stood up there and made that rope really taut, made it really tight. And then I walked around, I would create a circle, because every point that I walk on would be the exact same distance from the center. And that's how we create circles. When you look at your wheel on your tire, there's a center point, especially a bicycle, and then the spokes come off to the rim of the tire, right? That's what a circle is. Every distance from the center is the same, and so we create a circle. Now, the distance that comes from the center of the circle to any point on the circle, we call that the radius. So when you see R on a formula or anything dealing with geometry, it's talking about the radius of the circle, which is from the center of the circle to the outside perimeter of the circle. Does that make sense?
Yeah.
Now, the diameter of the circle is when you extend the radius so that you go through the entire circle and you half the circle to 2 hemispheres. And so if I have on the other side another R, then that's 2 R's, or 2 radiuses, which means the diameter of a circle is always twice the size of a radius. So that means if I have a radius of 5, then the diameter of the circle will be 10. Does that make sense?
Yeah.
Right? You take any bicycle and you go to the center of that bicycle and you look at that spoke and that's 5, or you go to the other side, that's another 5, so that's 10. And that's the relationship of the R and the D. So when you see R's in formulas, that means the radius, and when you see a D in that formula, it means the diameter. You have to know the difference. I don't think they describe it on the formula sheet, so you have to know D means diameter, which is the size of the whole circle, and R is just half of that distance from the center. All right, now when you're trying to find the perimeter of a circle, there's no corner points, so you can't add anything up. It's smooth. There's nothing where you can stop. I mean, technically there is, but we're not at that level. When you get on a higher level, you learn about things called arcs, right? And you can find the arc of a circle by going to the center and doing some trigonometry. But we are not doing trigonometry in GED, so the only thing we want to know is one smooth answer. And we call that the circumference. So when we want to find the perimeter of the circle, because we can't add up anything, we actually have a formula to find what we call the circumference. You ever heard of circumnavigate, or the circumference of the room, right? That just means to go around something. Circumvent, right? So anyway, this is the formula. C equals to pi times d. That little symbol there is pi. It's a Greek letter that denotes the ratio between the diameter of a circle and its radius. So the pi is
By our
approximately
school.
3.14. That's the value that we're going to use. That number goes on forever, actually, but they round it off, and in the GED, they use 3.14. In higher level maths, you have to use the actual pi, but 3.14 is sufficient to use. Now, that's also in the formula sheet. So if you go to the formula sheet, you scroll down, you see the value of pi on the formula sheet that you can bring up on the test if you forgot. Now, there is a pi on your calculator, but don't use it because you're going to get different answers. All the answers that you want to get are using 3.14. So if you see pi in your calculator and you're like, oh, I want to use it, don't use it. It's going to change your answers a bit. So pi is approximately 3.14. That squiggly line means approximate. So if you round something, you're technically supposed to use that symbol. When something actually equals to something, you use a straight line equals. So we're using approximately 3.14 when we're multiplying. Okay, so let's go ahead and try one of those problems. And then the other thing is the area of a area of a circle is pi r squared. All right, so let's go ahead and try one of these. It's a real life situation question. Workers at the Vista Hotel want to erect and just in case you're not sure, this is page 100. So workers at the Vista Hotel want to erect a circular fence around a circular swimming pool. They decide to make the diameter of the fence twice that of the pool. The workers need to know the circumference of the fence in order to buy the correct amount of metal fencing. So here you see the pool, and then there's going to be a fence around the pool, and you know you might have some people here on chairs. So anyhow, they want you to say, what is the circumference of the fence? What is the circumference of the fence? Not the pool. Fence. What is wrong with this thing? Anyway, what is the circumference of the fence that will surround the Vista Hotel swimming pool? Well, first of all, what is the formula that we use for circumference?
I think pi reduced square.
No, that's area.
That's error.
Just pi, pi d.
Pi d, right? So pi d. Now you might see in the formula page, you might see 2 pi r, and that's because 2 times r is the diameter. So if you see 2 pi r, don't panic or anything. It's just another way to write it. So anyway, we have pi times d. So what is pi equal to?
Pi.
Approximately. What did we write for pi?
3.14.
3.14, right? And then we times that by the diameter. Now, do we have the diameter of the fence?
25.
Close.
No.
Well, the diameter of the fence is double of the diameter of the pool.
There we go. The diameter of the fence is twice the amount of that of the pool. So how much is the fence?
50.
50.
50. So that means we're going to have 3.14 times 50, because that's the diameter. And what is 3.14 times 50 going to give us?
78.5.
Say that again?
78.5?
No, it should be higher than that.
Oh, okay.
157.
157. 157 meters. And you could have kind of rounded it. You could have said 3 times 50. That's about 150. So 157. You could have guessed that answer. 3 times 50 should have been around there. All right. So that's how you use circumference. Once again, if you forget what circumference is, you click the button on the formula page. You just go on there and click the formula sheet. And you're like, man, what's the circumference of a circle? And then you scroll down there and you're like, oh, it's pi d. And look, pi is 3.14. I just need to find the diameter and bam. Next question, please. I see something in the chat. I know it was just an answer. A little bit higher than that. All right, number 2. Hold on, let me read it first. We're reading, so you want to definitely have your book open. So number 6 says a circle has a circumference of, I think that says 47 inches.
Yes.
Okay, well done, eyes. Then it says to the nearest inch, so you're going to round your answer at the very end. What is the diameter? Well, what is this formula for circumference of a circle?
Pi times diameter.
Pi times the diameter. So C equals to pi times the diameter. But what did they give you?
They give you the circumference.
Circumference. So circumference is 47. Do you know what pi is already?
Yeah. So it will be 47 divided by 3.14.
Well done, George. You're going to divide both sides by 3.14. So 47 divided by 3.14 is going to give us the answer there. So what's 47 divided by 3.14?
Will be 14.96.
Right, so you get that whole number, but they want you to round it to the nearest inch. So which answer would that be?
15.
15 inches.
15 inches. All right, number 7 is pretty similar. It's with area. Can I clear this? Is anyone copying this down? All right, I'm clearing this now. You said you were writing?
No, I said I can't even read it. It's all blurry.
Oh, you don't have your book?
Oh, let me see.
This is on page 101.
Okay.
But did you get you copied down the work already?
Yeah.
Okay. All right. So number 7 is pretty similar, but this is dealing with the area of a circle. And the area of a circle, what is the formula for the area of a circle?
2 pi r squared.
Not 2 pi r squared.
Oh, pi r squared.
Pi r squared. Okay. So pi r squared. So we look at the question. They're looking for the radius this time. So that means you don't know what r is. But do you know what the area is?
Yeah.
What is it?
The area is 1,256 meters square.
All right. So I think it's 1,256. Do you know what pi is?
Yeah, 3.14.
3.14. And then we don't know what r is. Okay, so we need to solve for r, and now everything from here on out is algebra. You look on the formula sheet, you substitute the values in, and then solve. So how would we solve for r?
I think we need to divide.
Yes, well done. Divide by 3.14 on both sides. And what would that give you?
1, 2, 5, 6, 3.14.
400.
400.
400. Okay, so we have 400 is equal to r squared. How do we solve for r?
Divide by 2.
Not quite. We do the opposite of squaring. Now notice they have the answer there for dividing by 2. So be careful when you're dealing with squaring. What's the opposite of squaring?
Square. I think square. We divide. No.
The power.
Multiply.
The opposite of squaring is the square
Root.
roots. Remember, you cannot forget that. You will be lost without remembering that rule. The opposite of cubing is the cube root. The opposite of squaring is the square root. You need to write it down, put an asterisk on it, put it on your head, put it on your computer somewhere, but you want to make sure you remember that. The opposite of squaring is the square root. The opposite of cubing is the cube root. So we're going to square root both sides. And when we square root both sides, what is the square root of 400 going to give us?
40.
I heard a few answers there.
I got 20.
20, that's correct. So the square root of 400 would be 20, so our answer there would be B. Is that making sense, how to do all of the algebra?
Mm-hmm.
Yes, sir.
Okay, good.
Yes, sir.
All right, number 8 is an interesting one. I might just have to work it straight out, but I do want to skip over to the other stuff. Just to kind of give you an idea here, for a question like this, you want to find the area. Let me just read what they want. Yeah, they want this area here. So a question like this, you'll find the area of the big circle, as if you found the whole thing. So you find the area of the big circle, you subtract, well, what are they asking? Hold on, let me read the question first. The rug is divided into white interior and gray border. What is the area of the, okay, I know there's asking for the gray area. Okay, this one was actually easier. You're just finding the area of the white rug. And so this one here, you would have just used 4. And so that would have been area is equal to pi times 4 squared. And so that's simply 3.14 times 16. If you had to find the gray area, that would have been a little bit more work there. But if it was a gray area, you have to take the area of the whole circle and then subtract the area of the smaller circle and it'll leave you with the gray area, if that was the question. All right, so this one would be 50.2. Right, just find the radius, put it into the formula, work it out, done. And you can master geometry relatively easy. All right, that's our 2-dimensional shapes. Then you have the composite planes. We did this already, but there's an interesting question here that's a little bit different than the ones we did at the very beginning, and that's number 2. Any ideas on how to find the area of this shape? This is similar to the very first thing we started. To kind of help you out, if you were doing number 5, you could split number 5 into this one area, plus the other area, plus the third area. Or I could have even split it up this way. I could have said area 1, area 2, and area 3. Or I could have split it up this way. I could have said area 1. That looks crazy. I could have split it up this way. I could have said this is area 1 plus the area 2 plus area 3. Either way, you still get the same answer no matter how you split it up. So that's what we did in the very first questions, like the third one. How would we do number 2 then, using the same idea? Well, we want to split this up into shapes. How many shapes do you see here?
3.
3, right? You see a half of a circle here. You see a rectangle here. And then another half of the circle. Well, what can we do with the 2 halves?
That's a problem.
Make it a circle.
We can make it one, we could act like it's one big circle. So in reality, we can just say 1, area 1, and then these both can be area 2 because we can put them together. In essence, like we can pull apart the rectangle and then push the circle together. And then we have 2 shapes. We have the circle and a rectangle. Does that make sense?
Yeah, but Mr. Ryan, what could be the area? Because we don't know the area, even one part of the...
Yes, we do. We have everything we need to find the area. So let me show you.
Okay.
If we find area 1, well, that's a rectangle, right?
Yeah, it's simple. 40.
That's very simple. 8 times 5.
Yeah.
And the idea is that my total area is going to be equal to area 1 plus area 2, right? So my first area, A1, is going to be 8 times 5. That's the area of the rectangle. And then my second one is going to be the area of the circle. And how do we find the area of a circle? What's the formula? You can look at the formula page.
Which is,
Pi r squared.
Pi r squared, right? And do I have my r? Look at this shape carefully. Do I have the radius of the circle?
0.5.
Say it again.
2.5.
2.5, that's correct. 2.5 is that circle. And that's 2.5 squared. And we use pi as 3.14. So let me replace that pi with 3.14. So basically we did length times width plus pi r squared. Does everybody see that? We took the rectangle and we're adding it to the circle. Now you could have done half of the circle plus half the circle, but if you have half a circle and half a circle, you might as well say 1 circle, right? So then we just work this out. 8 times 5 is 40. You can put it straight in your calculator. Your calculator can do that whole thing. So let's just do that. You can just 8 times 5 plus 3.14 times 2.5 and hit your square button. And what answer does that give you?
59.625.
There you go. That's your answer, 59.625. All right, so this question is a very popular question because this shape is a very popular shape. It could be a pill. It could be a football field with the track and field going around it, right? You know, the runners are running around the field, and then people in the middle of the field are throwing javelins and shot put and stuff like that and doing long jump, right? That's a track and field track. This question appears a variety of ways in a variety of curriculums and tests. It's a very popular question, and you can see it come up a lot. Anything that you can compose and break down a shape into multiple pieces like this, right? Splitting the shape up. Same thing with the perimeter. They don't ask you for the perimeter here, but I'm gonna give an example of perimeter. How would we find the perimeter? Any ideas?
We add
all the sides, but
all the sides.
Okay, what are the sides?
8 plus 8.
plus 5 plus 5.
No, not 5. 5 is in the inside.
Okay, okay.
Just
So
8 plus 8.
we can draw around it to help us. We have this side, right? We have this side, and what are the other sides over there?
Maybe 5.
Somebody said it. I thought I heard it.
2.5.
Say it again.
2.5.
No, not 2. Well, 2.5 is part of it. What is a perimeter? So that's, if you look at it carefully, that's the outside of a circle, right? I'm doing half of a circle on one side and half of the circle on the other side. So that means I can find the circumference of the circle, or pi d. Does that make sense?
Okay, yeah.
Right? That's the outside of the circle. If you were running a track and field event, let's say Usain Bolt is running, he runs down the straightaway, he turns the corner, and then he runs down the other straightaway and turns the corner. And the corners create a circle. And so if I want to find the outside of the circles, then simply that's the circumference. And the circumference of a circle is pi d, which I can see right here. So when we add up this one, and this is another popular one, finding the perimeter of that shape. Very, very popular. I wouldn't be surprised if you saw it on your test. You do the 8 plus the 8, right? So our perimeter would be 8, this 8, plus this 8, plus the outsides of the circles, which is simply pi d. Now, I just need to know what my pi is. What's pi?
3.14.
3.14, and what's the diameter of this circle?
2.5.
Diameter.
Okay, diameter should be
5.
5.
Now, if you use 2.5, you have to use the other formula, 2 pi r, and that can get confusing, so let's just stick with pi d. All right, so you just work that out. If you needed to find out what the perimeter is, that would be, our answer would be 31.7. So that would be the perimeter of this tablecloth. Does that make sense?
Okay.
Yeah.
Okay, good. Remember, you can always watch the video again if it's going too fast, but hopefully you're seeing. All you need to do is to look at the formula sheet to get what the formula is, and then remember, geometry is real life. Like if I asked you, if I wanted to put a border around your computer screen, just think about what you need to do. You know, if I was putting a border on the screen, you're going to look at the outsides and you need to just figure out what they are. That's how you want to approach any geometry question. Act like it's a real life situation. You're just going to put a nice border on the side, or you're going to find a case for it, right? And if you think that way, verbally, and like I said here, I need to find this area, but it's all weird shape. Well, let me split it up and find this one, and then find that one, and find this, and add them up. Okay? All right, hopefully that has helped out a good bit. We're going to skip all those. And I think this is probably the last thing is, let me skip this one. We're going to go to number 106, page 106. I talked about this in the very beginning, prisms. Remember I was saying a prism is any three-dimensional shape, where if you look at just the front, it will look like a two-dimensional shape. And because of that, the formulas for them are very, very simple, which means all you do is find the area of the circle, which is pi r squared. So when you want to find the volume of a cylinder is pi r squared, and then you multiply the third dimension. And so in this case, it's height. And that's the volume for a cylinder, pi r squared times the h. And if you look at the formula sheet, you see that there. You look for cylinder is here. The volume of a cylinder is here, pi r squared h. And that's very simple because you just have to find out what, you know what pi is. You find the radius of the circle part, and then you multiply it by the height of the can. So if you're dealing with a can of beans, you say, you find the center to the side, it's the radius, times it by 3.14, times it by the height. And that's the volume. Literally, when you look at a volume that's written on the outside of a can of beans, let me just see here. Do you guys see my internet thing here?
Yeah.
Yes, sir.
If you look at a can of beans, and you see it says 15.5 ounces, and on the back they'll give you the thing. That's how they find it. They do pi r squared times height. They find the top of the can, and then they times it by the height of the can, how tall the can is. And then, bam, you have it, 15. You have your volume that you're going to use. All right, I can't even get back now. All right, so same thing with the prism, the rectangular prism and the triangular prism. If you look at all the formulas there, for each one, if I could get back there, the formula of a rectangular prism, length times width times height. And you should be able to find out what the length is, what the width is, and what the height is. All right, so that's how you do it. This one here, a right prism, is just basically saying a square prism or a cube, which is just fine. When you see that big B, it just says find the area first and then times it by the height. That's exactly what I've been saying. That's what the big B times the H means. It means you just find out what the area is of the front piece. And by the front piece, what I mean is this. You find the area of that piece here, the triangle, and then you multiply it by whatever the long part is. Area of the square, multiply it by the long part. Area of the circle, multiply it by the long part. Does that make sense?
Yep.
Same with the rectangular prism, right? If you see it this way, area of the rectangle, times it by that longer part. And that's how you do all of them. And the formulas are there, so all you have to do is identify. So for instance, this one says what is the volume? So they give you the radius. They said 3 inches, I think. Really
Yes.
make it out. And the height is 6. So I know it off my head. That's pi r squared. That's the area of the circle. And then the height, which is the long part. So that's 3.14 times the radius is 3 squared, which is 9 times 6. And you can put that right in your calculator. 3.14 times 3 squared is 9 times 6. And that gives you, hold on, I know it's something different. Can't really see that. Oh, that says 8 inches. No one corrected me? 8 inches. So, yeah, I'm tired too. So remember, if you need to watch it again, so this would be 226 inches cubed. All right, is this overwhelming or is it making sense?
It's making sense, Mr. Ray. Mr. Ray, I know you put all the videos up on the YouTube. This will be the last one that you're missing. Maybe we could get that one there too.
Yeah. I don't think I put Tuesdays up, so it'll be Tuesday and Thursday that's left. This Tuesday. Well, Tuesday was taking the test, so it'll just be this one.
I think it'll be just this one, yes.
Yeah, it'll just be this one because I didn't do anything on Tuesday. You just see us talking about how to look at the test and stuff. All right, so that's how you would do those type of shapes. So an example here and there, rectangular prisms. All right, let's see if I could get the last two things we have to look at. All right, this is the last two. I'm hoping we can get to it. Now the cone, the sphere, and the pyramid. This is where, George, this is where the slant height comes in. Remember I talked about slant height? This is where the slant height actually matters. The only problem is you need Pythagoras theorem if you are given a question that wants the slant height. Same with the pyramid. In order to, if you don't know what the slant height is, you're going to have to use Pythagorean theorem. And like I said, I wasn't going to touch on it tonight, but it's not a hard concept to do. You could YouTube it. I mean, you can learn it in no time. It's a pretty straight, if you already know how to do distance formula, finding the slant height is not hard. All right, so the thing is, you just want to be able to identify all the pieces. Normally, they give you the slant height. So hopefully they just give you a normal question. So you need the slant height in a cone problem. You need the actual height and then the base, right? A cone like an ice cream cone. With a sphere, is really simple. All you need is the radius, that's all. And then with the pyramid, very similar. You need the slant height, you need the height, and then you need the base. And so they don't give you too many of these, but when they do, it's not that difficult because guess what? The formula is there. And in the formulas, they give you exactly what you need. So if you're looking for the pyramid, they tell you in order to find the pyramid, and this is what a pyramid looks like. A pyramid has a square base every single time, and then it meets up at the top. So to find the pyramid, that big B means the area of the square. So that means if you have a 3 or a rectangle, depending on what it is, if you have a 3, 5 there, you find the area of that, which is 3 times 5. And then you find the height, which is from the top to the bottom. And then you times it by a third. And that's how you find the pyramid. So once again, if you go back to, if you come back here, if you look at a pyramid like this one, they don't have any, okay, bam, this one here. They want surface area. This one's asking for surface area. So if you're looking for the surface area, you use a different formula. So the surface area, think of surface area as wrapping a gift. So let's say you had a bowl you're trying to give to your child, you wrap the bowl up. Well, when you wrap the bowl, that's called the surface area of the sphere. If you used to put air inside the bowl, that's called the volume. Does that make sense?
Okay.
If you were selling ice cream cones, then you wanted to put chocolate around this area of the cone, that's this one. And if you wanted to fill the cone up with ice cream, that's the volume. If you're dealing with a cylinder and you wanted to put a nice wrap around the cylinder saying bush beans, well, that's what we call the surface area. And then the volume is actually putting the beans inside of the can. And lastly, a rectangular prism is a box. You get a box from Walmart or somewhere, and you want to wrap it. The wrapping that goes around the box is what we call the surface area. And then the volume is what's inside, what you put inside the box. Does that make sense?
Yes.
That's how you know the difference. All the signs are there, the L and the W, length and width. P just represents perimeter of the base. And you can always try them with your book open. And that's how you would do the 3-dimensional shapes. Now with the last few minutes, I know it's been a lot, but you can always rewatch it on YouTube, is something that we've done already, but it's an application question. And that's right here, similar triangles and congruent figures. Remember the word congruent just means equal. So an example of equal or congruent figures is the tires on your bike. They're the exact same size, exact same shape. So we call them congruent. But an example of a similar shape would be your tire as an adult, and then let's say your child's tire. They're different sizes, but they're the same shape. When that happens, we call them similar. Or even a model car. You have a model Ferrari, and if you look at the bottom, it says drawn to scale. That's an example of a similar figure, where the tire may be drawn to a ratio scale, meaning that if the tire on your car, your toy car, was 1 to 15, right? You say 15 to 1 or 1 to 15. That means if your car tire was 3, then the real tire would be 3 times 15, which is 45, right? Now we did that in ratios, and that's exactly what you do for these things. When you see something like this, a similar shape, and they're asking you to find the missing side, and that these shapes are similar. What that means is that they are proportional to each other, or they can be written in form of a ratio. And all you have to do is make sure that whatever side you pick, you stay consistent. And so let's say you're looking for this side. I think that's exactly what you're looking for, AC. Yeah, you're looking for AC. And so AC is this side here. And you write it as a proportion. You write it as X over 4.2. And then you write it as equals. And then you take whatever this side is similar to, and you write it on the exact same line, 1.2. And then you take this one and you write it over 2.1. And this way you're able to figure out, because they're in proportion and you're using proportions to figure that out. And if you multiply it, you may remember this, cross multiply, you get 2.1x is equal to cross multiply here. And that's 1.2 times 4.2. And if you do multiply that out, 1.2 times 4.2, it's going to be equal to 5.04. So you have 2.1x is equal to 5.04, and then solve for that by saying 5.04 divided by 2.1. And if you divide that by 2.1, you get 2.4. And if you scroll down, you see 2.4 is selection C. Now, once again, we've done proportions already. The only thing you have to know when dealing with these is just how to write out the proportion. It's just, if you choose this side, the other side has to match. Choose this bottom, it has to match with that. All right, I know that's a lot of information, but hopefully it's going to help clarify a few things, because if you're taking a test and this helps you by boosting you 5 points, and that's all you needed to pass, then woohoo! All right, did that make sense, that last question that we just did there?
Yes.
Yeah, I got one yes. That's good. Did I get 2 yeses,
yes,
or maybe?
Yes, sir.
Okay, great. Now, I'm going to do one more. If you have to go, I totally understand, and it's great having you guys this semester. If you signed up for any of my classes next semester, it'd be great to see you. Once again, and Justine and Marisol, I have to give you your vouchers, but I just want to do one more just so you can see it. But for those of you who have to run, it was great having you. I'm just going to finish off this second one just so you can see how it works one more time. This one's asking for length FG. FG means you start at F and you end at G. The triangle FGH just means you start at F, then you go to G, then you go to H. So if you want to find this one, that's X. And so if you wanted to write this as a proportion, just like we did at the beginning, this one is similar to this one, and 5.4 is similar to X. Now for this one, I don't know if you noticed, but what is the relationship between these two if they are in proportion to each other? This one,
Half?
yeah, one of them's half the size of the other, which means the other one is double. If I wanted to find this side, I could just times it by 2. And 5.4 times 2 is 10.8. And for this one, 5 times 2 is 10. And I could quickly find that just by noticing that one is double the size of the other. Did that make sense?
Yes.
And then to find the perimeter, I just add them up. 10.8 plus 10 is 20.8, so 24.8. Now that's just by noticing, but sometimes, as you saw, it might have a decimal relationship. But I do want you to see that if you write this up as a proportion as well, you still get the same answer of 10.8. And that is by comparing the 2 to the 5. So you write 2 over 5 is, no, sorry, gotta first make sure you know what you're looking at. You're looking at this X. So you want to do 2 and the 5.4. So you put 2 over 5.4 is equal to 4 over X. And you make sure that the related sides match up. 4 matches with the 2, and the X matches with the 5.4. Once you set it up, it's the same proportions we did at the very beginning of the school term. You multiply diagonally, so you get 2x equals 2. You multiply the other diagonal, that's 5.4 times 4. 5.4 times 4 is going to give you 21.6.
Man.
And then you divide both sides by 2. And 21.6 divided by 2 is We gave you 10.8. It's the same answer you got just by observing that it was double the size of the triangle. Okay, I know, like I said, I know it's a lot of information, but I hope that this information is all you need to ensure that you pass the test if you are one of those that are going to take it this time. All right, that was a lot of information. You've almost covered 100% of this curriculum. If we had that last week, next week, we technically would have finished the whole book. But if you review the videos, it can really help you to remember what we have covered. It was great having you guys. I must say you guys are one of the top classes that I've had. This is one of the only classes where I've had so many people understand the material. I even told the principals that you guys are definitely one of the top groups. So feel very well about yourselves. And when I asked her, she went back and checked. She said, yeah, you had an extraordinary group. She checked your CASA scores, and she's like, man, you had a good bit of students who had great CASA scores, tests, and whatnot. So you just keep in mind that you guys did very well this term.
Thank you.
Great. I have one question.
You're welcome.
Thank you so much.
You're welcome. You guys are going to do well. And I heard somebody ask if they had a question.
Yeah, Mr. Ray, you're gonna leave we're gonna have access to the videos at least until the.
Yeah, I'm just gonna leave those up. I'm not gonna take them down.
Okay.
Yeah.
So we have access to remind we can access those videos, right?
Yeah, I keep remind up until like probably midway of the next semester typically.
Okay. I'm gonna keep on watching the videos until I pass the test.
Yeah, sure. You have access to it. I doubt I'll take them off because I have them unlisted, so no one can find them unless they have the link. So I'll just leave it up.
Okay.
Please upload the last two so you can have all of them.
You mean this one? Because last week was just us talking about the tests and stuff.
Okay, so yeah, this one.
Yeah, this one. Okay, yeah, this one would be uploaded right. But I have to wait till it finishes, and once it finishes, I can upload.
Okay, appreciate it. Thank you so
All
much,
right,
sir.
you're welcome.
Mr. Ray, thank you very much.
You're welcome. You guys enjoy your evening.
Nice meeting you.
Yes, it was great meeting you.
Bye,
Keep up the good
guys.
work, you guys.
Maybe we could see on
Bye.
All the
Monday,
best in
Tuesday.
all your endeavors.
Bye, everybody.
Bye.
Bye.
Marisol, John.
And
Bye,
Marisol,
guys.
all right, bye.
Bye.
Justine and Marisol, I'm just going to get you guys vouchers real fast. Just make me a promise that you will take it because they paid for these already.
Yes, I'll take it.
Because I'm going to report that you guys have taken it. So just looking for that real fast. Okay, I should have it to you in a moment. I forgot who's Stacy. And which class is this? Okay, Justine, you're first on the list here, so I'm just going to send you yours. And do you want it on here on the chat, or do you want it on the remind?
It doesn't matter, whatever is easier.
Okay, good, because I think it's just copy and paste, really.
Okay.
All right, so the voucher, and you know how to use the voucher, right?
I'm sure I could figure it out.
Yeah, well, I'll show you real fast. It wouldn't take that long. Let me just get Marisol's, and I think you guys are savvy. You just have to make sure you click the bottom one. If you click the top, it doesn't work for some crazy reason. And so a lot of people are having trouble with it in various classes because you have to click a certain button. All right, so did you see yours, Justine?
Yes.
All right, and then Marisol, I'm sending yours right now. Do you see it?
Yes.
All right, so then let me just send you the link and you can just put it on the side once you're done. The link is if you already have an account, then it shouldn't be hard to find the link there. But it's simply GED Ready, My GED Ready. And I'll send you that link right here. And I'm sending it to everyone, so you guys will all see it. All right, so that's the link. If you click that link, it takes you here, and you just want to make sure you click this button down bottom, not the one on the top right. If you do that one, it doesn't work properly for some reason. So you click in log in, you already have a voucher. And once you click in there, all you want to do is just click on study. And then from there on, and make sure you sign in, of course. So you sign in, and if you haven't had an account, you want to sign up on that same little area right there on the bottom. Make sure you click math, and then once you get through there, choose your language. And then the last thing is just make sure you click study so you can get there. Once you do that, you click proceed to checkout, and you click all that yes stuff there, and you put it in the area right there, voucher promotion code.
Okay. Okay.
All right, if you have any troubles, just send me a message.
Okay.
All right, you guys both have it, right? You copied it down already?
Yes.
Okay, Justine, you have it?
Yes, I do.
All right, you guys enjoy the rest of your evening. I hope you do well in all your endeavors. I think you guys got it. And thanks for attending class today.
Thank you, Mr. Ray.
Thank you.
You're welcome. All right, have a great evening.
You too.
You too.
Bye.
Thank you.
All right, bye-bye.
Bye.
All right, George, have a great evening as well. You did very well. Are you taking the test?
Yeah, I take the test.
All right, so you took, how are you doing the practice test?
I've not come across my scores. I will check it now.
Okay, I think you're gonna do well. You do well in an upper level class because you got a lot of questions, and that's what they want in upper level, so keep it up. I know I sometimes will be rushing, but that's only because we're in the GED. But if you was in a university, they would love those type of questions. Those questions allow you to go really deep. The only problem is we're trying to finish so much stuff in a short time. But keep up the questioning. That's what mathematics is. I appreciate the questioning. It actually helped out. So well done. And if I don't see you again, hopefully if I hear about you, you're some big time CEO or something of a company or something.
Okay.
All right. Have a great evening.
Thank you.
All right. Okay. Bye-bye.
Bye.